Hello, and welcome to today's session on observation. This is the second video on observation. Earlier we had talked a little bit about different kinds of observational paradigms, and we had mentioned that some are direct, some are more indirect, some of them suffer from issues like reactivity and so forth. Today we're going to go a little bit further and assume that we've gone through some paradigms of observation, and now what we want to do is take a look at such issues as measurement scales. That is, how do we begin to combine all the information that we might get from our various observational paradigms? And we'll also consider some other factors associated with observational paradigms that would really be independent of the particular paradigm that you had used. As always, before we get too far, please make sure that you have the PowerPoint lecture notes in front of you. It may also be helpful for you to be on a computer screen so that you can, and on the web, so that you can click over to a video, or you can access the web if you want for searching for information or doing something else that you think is really relevant to this, like maybe finding a relevant video or a relevant picture on the web. So we'll let you get all set. And then when you're ready to begin, we will jump right in and talk a little bit about measurement scales. Okay? Measurement scales are going to be important for helping us to summarize the information that we've gotten from our direct observations, our indirect observations, and so forth. And we're going to be talking about 4 different kinds of measurement scales. Typically, we measure them along these 4. One is said to be nominal, one is said to be ordinal, then interval, and then ratio. And there's a sequence here. We typically talk about these in a sequence that goes from the crudest to the most refined. So our nominal scale is going to be our crudest kind of measurement scale, and our ratio scale is going to be our most refined measurement scale. The type of scale that we use is very important. When we're designing our study, we want to think very carefully about what kind of measurement scale we might use, because it will set a limit on what kinds of things we can do statistically during the analysis phase of our study. So let's go ahead and take a look at each of these. We'll start out with the crudest of the scales, the most rudimentary. This is called the nominal scale, and I'll give you a few different synonyms for the nominal scale that you might see in the psychological literature. We sometimes call a nominal scale a categorical scale, or sometimes a qualitative scale. The word nominal itself means in name only, and you might be able to appreciate that point if you think a little bit about some of the examples that we have here. So the levels of a nominal scale are either category names like male and female, or dummy numbers arbitrarily, and that's a critical word here, arbitrarily assigned to categories. So for example, we might think about the number of majors in psychology in a particular university, and we might say that we're interested in counting how many males and how many females we have. If we're doing a checklist of males and females, we might put a simple code of 1 for male and 2 for female. In this particular case, we're using those numbers arbitrarily. There's no implication that the number 1 and the number 2 have any magnitude here. We're using these numbers as placeholders, in name only. We do this also when we watch television. We might be watching channel 4 or channel 8. In many contexts, 8 is twice as large as 4. But here, we're using 8 and 4 just as placeholders. They're just describing these different channels or referring to these different channels without actually suggesting that channel 8 is twice as big as channel 4. That's simply not the case. We're using these numbers nominally. So the only permissible arithmetic operation on nominal scales is equal to or not equal to. That is, we would say that on this gender description, male and female are different categories. They are not the same category. Channel 8 and Channel 4 are different categories. We're not able to say, though, that one of those is greater by definition than the other one is. Now, it might turn out that we have more observations in one of those categories than we have in another category, but the category itself is just meaningfully distinct from the next. It's not as if it was larger or smaller. Okay? So nominal data are often reported as a percentage of observations in each category. Again, we might say something like we had 70% female psychology majors and 30% male psychology majors, whatever the categories might be. Here's an example that might be of interest to you. We'll give you a real-life behavioral example. You might notice when you're walking around campus that people are carrying lots of books. And what we might be intrigued by is that there are some perhaps gender-specific patterns in book carrying. So what we can say then is that one of the variables of interest in our analysis of whether there are gender differences in book carrying behavior is that we have a variable named gender, and it has male and female levels. Okay? And we might arbitrarily number those 1 and 2 if you're so inclined. What we would then do is come up with a few different categories of book carrying. So here I've got a book, and it might be the case that some people carry their books across campus in this kind of a manner. They cross their two hands, they hold it against their upper torso, and they walk like this as they're moving across campus. Okay? Another type of book carrying behavior might be that we hold it just in one hand and off to the side. Okay? And so now people are locomoting around campus kind of like this. Okay? And then it might be that we have some third category where the behavior is entirely unusual, that maybe for a brief period of time somebody's carrying the book on their head, for example, or they're carrying it back here, or they're doing something that doesn't neatly fall into this category, side carry, or this category of cross carry. So what we can say then is that we might have 3 general categories of book carrying behavior. One is side carry, one is front cross, and one is other. And we can look across the campus and we can make behavioral observations. Maybe we can do this in a naturalistic way without directly interfering with anybody. We could even use a hidden camera if we had IRB approval to do that. And we could make a note of how many folks are male and female, and within each of those categories, who's tending to carry their books like this at a particular moment, or like this, or in some other way. Okay? Then we would have a couple of variables, each of them coded now nominally. We'd have one for book carrying behavior, it would have 3 levels. We'd have one for gender, gender would have 2 levels. So this would be an example of an observational study that would be employing nominal scales. Let's now move on and get to our second measurement scale. This is now 1 level more sophisticated than the nominal scale. We call this a ordinal scale, and it reflects rankings. We sometimes call this a rank scale. Okay? So unlike the nominal scales, ordinal scales permit greater than and less than comparisons. Okay? In 1990, proponents of the Gulf War argued that caution was needed because Iraq was the 4th largest army in the world, and that's true. Iraq at the time really did have the 4th largest army, and when you think that there might be more than 130 countries across the world, to have the 4th largest army of 130, that might seem very formidable. On the other hand, that can be a little bit misleading. And the reason is that the first army, probably the largest army, would be the US Army in terms of military strength. In terms of numbers, probably the Chinese Army would be the largest. And those 2 armies, the Chinese Army and the American Army, the US Army, would be so much larger than whoever is in 3rd place. It's a little bit misleading to say that, well, 3rd place is similar to 2nd place. And to be in 4th place, have the 4th largest army, as Iraq did, is really quite misleading. Yes, it's the 4th largest, but it's quite a bit smaller than who's ever 1st or 2nd. Okay? So what's misleading about this statement is that we know that we don't have any way of actually quantifying the distance between the various ranks. The distance between 1st and 2nd place can be very small, or it can be huge. The distance between 2nd and 3rd place can be very small, or it can be huge. There's no requirement in an ordinal scale that we have even intervals between the various ranks. So it does allow us to get a little bit more precise information about the values in each of our observations than a nominal scale would. But it doesn't allow us to say with any precision what the intervals are. We only know that one is being larger than the other without actually specifying the magnitude by which that is true. Okay, unlike ordinal scales, interval scales, if we go up 1 notch again, indicate the distance or the interval, what we'll call it the distance, between values on a given dimension. Okay? So now we have a critical feature, which is that our measurement scale has even step sizes. So the distance between number 1 and 4 is the same distance as between that of 4 and 7. There are 3 intervening steps, and all steps are of the same size. The difference between 32 and 33 would be the same interval as between 98 and 99. There's a step size of 1 in each of those cases. And the step sizes are always of equal interval, and that's how this scale gets its name. It's the interval scale. Right? Here we can now begin doing some arithmetic operations that are actually meaningful because we have equal intervals. We can do such things as addition and subtraction on interval scales. 98 minus 97 really is 1 on an interval scale, and 4 minus 3 really is 1 again, even though 3 and 4 are in a very different place than 98 and 97. That step size is the same. So some arithmetic operations now come on board in a more meaningful way. We can at least do addition and subtraction. Multiplication and division can be done, but there has to be some caution that I'll talk about in just a moment. Interval scales do not have an absolute 0 point, so ratios can't be performed. This might be the most subtle point of the entire video, and I find that year after year students struggle with this idea of an arbitrary 0 point, not an absolute 0 point. So we'll see if we can take an example. Some of you might know that it's very practical for us to have a Celsius scale when we're talking about temperature. And one of the reasons why it's practical is that the founders of the Celsius scale took a few very relevant temperatures for our day-to-day lives. For example, we might want to know whether it's icy outside. We want to know the temperature at which water freezes. So the researchers who developed the Celsius scale assigned a value of 0 to the temperature at which water freezes. The temperature at which water boils is 100 degrees Celsius. So now we have 0 and 100 corresponding to very meaningful aspects of water, which is so important to human life. When is it boiling? When is it freezing? But actually, if you remember from maybe your high school chemistry class, it's really not true that 0 degrees Celsius corresponds to the state of absolutely no molecular motion. And if you remember just a little bit about your chemistry class, you might recall that the phenomenon of heat is actually an index of molecular motion. Hotter things have greater molecular motion. Cooler things have less molecular motion. So there's actually quite a bit of molecular motion going on in an ice cube of water, even though the ice cube is in fact momentarily in a solid state by our standards. Okay? But this doesn't mean that we have no heat whatsoever. It doesn't mean that we have no molecular motion. It just means that we've arbitrarily assigned 0 to the scale because it might make sense to do that for practical reasons. Okay? So that's an arbitrary assignment of that value. Here's one other. Sometimes two examples are helpful. Let's say we want to measure height for some particular reason. Maybe we're health psychologists and we want to understand the relationship between height and some aspect of health, maybe something like heart attack. Okay? And maybe we want to see if there's a covariation between height and heart attacks or strokes or whatever the case might be. Okay, so what we can do is we can use a typical scale like centimeters, or we can use a typical scale like inches as our variable for our unit for measuring height. What we could do instead is we could assign an arbitrary value for height in centimeters or in inches, and we might, for example, say that I'm 5'7", so we're going to make that the standard, and we'll call that the 0 height. If you're 1 inch taller than me, you'd be 5'8". We would call that +1 on the scale, which has been arbitrarily set to 5'7" as our 0 point. If you're 5'9", you're now 2 inches on this scale because you're 2 inches taller than I am. If you're 5'6", you're 1 inch shorter than I am, so we would give that a score of -1. If you are 2 inches shorter, you'd be 5'5". You're down here at -2. So we go from -2, -1, 0, +1, +2. But that 0 is entirely arbitrary. I happen to have a height that is actually non-zero, right? My height really is 5'7", but in a particular scale, a interval scale, we can arbitrarily set it to whatever we want, and sometimes it's very practical to just get rid of that baseline height or the baseline weight or the baseline whatever and set the middle of what you believe your scale to be to 0 and have numbers float negatively and positively as those observations come in. Okay? All right, so this is an example then of an interval scale. Let's move it up one more time and talk about the most ideal scale that we can have. It has a lot of the properties that the interval scale has, but it has one additional property. Okay? The scale that is a ratio scale actually does have a real, an absolute 0 point. And what this would mean is that we can say that we have absolutely none of a quantity. So you could have no height whatsoever. There could be some object that you're measuring that isn't extended at all in space. Okay? It has no height whatsoever. You can imagine that we can measure something on a clock, and if the clock begins and stops immediately, we would say 0 time has elapsed. we could say that in principle, you could find an object that has no molecular motion. And because it has no molecular motion, its temperature is, in an absolute sense, 0. This would be like the Kelvin scale. Okay? Kelvin scale of 0 really does correspond to the state of absolutely none of that quantity, which would be molecular motion. Okay? So now, because we have a meaningful 0, we can say that we can do ratios and we can do multiplication. Okay? Just to make the distinction between an interval scale and a ratio scale really clear, let's see if we can appreciate this point. If we pretend for a moment that we'll say 130 pounds, okay? And we're going to now go back to an interval scale, and we'll set my 130 pounds to be 0. Somebody who weighs 132 pounds would have a score of +2 on that interval scale. Somebody who has 131 pound weight has a +1 value on that scale. We would not say, though, on that interval scale that somebody who has a score of 1 is half as heavy as somebody who has a score of 2. That would be a very misleading ratio, because in actuality, the person who has a score of 1 has a weight of 131 pounds. The person who has a score of 2 has a weight of 132 pounds. 132 is not twice as big as 131, and that's why we can't call that interval scale a ratio scale. We can't say that there's a 2-to-1 ratio in any real sense happening on that interval scale. By contrast, if we're using a ratio scale, and we're saying now that I weigh 130 pounds rather than 0 pounds, and we find a football player who weighs 260 pounds, that football player really is twice as heavy as I am. The 130 to 260 ratio really does make a 2-to-1 ratio in this case, or 260 to 130 is a 2-to-1 ratio. And this is how we can now begin doing such things as division, which is how we get our ratios, once we have, in fact, a ratio scale. So it'll take a little bit of practice to get used to these scales, but just the big picture idea that you should take away from this is that we have these 4 different measurement scales that go from very crude to very refined. They permit different kinds of arithmetic operations. Simple, same, different, versus this is greater than that, but we can't say by how much, versus we can do multiplication and division at the extreme, or maybe before we get to that extreme, we can do addition and subtraction on the interval scale. Okay? All right. So what you should do now is take just a little break, stop the video, and make a note, if you can, of what you find to be particularly clear about measurement scales, and what you think might require greater clarification. We'll give you a moment to do that. Okay, welcome back. Now that we've talked about measurement scales, we'll go on to some other important considerations for observational paradigms. We can talk first about data reduction. After you've made some decisions about what kind of measurement scale you're going to have, maybe it's nominal, maybe it's ordinal, maybe it's interval, maybe it's ratio, we'll need to engage in some data reduction. And we can define this as the process of abstracting and summarizing our observations. Sometimes the observations are qualitative. And when it is the case that we have purely qualitative observations, then what we might do is try to find some themes. Maybe we have a narrative that we're working with, and we're going to look at the narrative very carefully and see if we can identify some recurring themes. And that might be how we begin to reduce this ongoing narrative to a summary that might be a little bit more manageable for those who are consuming the research that we're producing. And that would be the case if we have some qualitative data. For quantitative observations, the data reduction involves identifying central tendency, which we've talked about before, dispersion. We might identify some outlier scores, and we might even identify some impossible scores. So let's just remind ourselves about some of this terminology. We've said before that central tendency is typically measured as mode, median, and mean. We've had a few different indicators of dispersion, such things as the range of scores, the lowest and the highest, maybe the standard deviation, which is the extent to which a score departs from a mean on average. Okay. We can also look for some outliers. We can say that maybe all the scores are clustering around a certain value, plus or minus a certain number of units, but maybe we have one score that's very, very much lower than the others, or very much higher than the others, and we can ask ourselves the question about whether it's fair to include that point, or whether we should somehow circle it, call it to the attention of our reader, but maybe exclude it from our analysis if we say and remind our reader that we are excluding the outliers, and we might even tell them what the criteria had been for excluding that particular outlier. But we don't want to have our central tendency skewed dramatically by a small number of outlying points, and we need to be honest with the reader about what we are going to do with those outliers. There's also this interesting idea of impossible scores. Sometimes you'll be recording data, and you'll find that you have a score that is genuinely out of range. I'll give you an example. Let's assume that you're doing some educational work, and you want to look at the link between college GPA and somebody's score on the SATs. The SATs, either the verbal section or the mathematics section, for example, can range between 200 at the low end to 800 at the high end. That's the full range of scores. Suppose we happen to have a particular score in our data sheet that says we had an SAT score of 190. That's really not a possible score because the range is 200 to 800. Somebody must have misencoded that when they were typing the data set in. So as we're engaged in data reduction, we have to ask ourselves, is that score plausibly even in range, or must that reflect some kind of error, maybe a data entry error or some other kind of error that we had? Maybe somebody believes they scored 190 or that they scored 810, which you and I know is not possible given the range of possible scores. Okay? So we can look for impossible scores, outliers, dispersion, and central tendency when we're engaged in data reduction. The next concept that we have is coding. Okay? We can ask ourselves about the process of classifying units of behavior, okay, or of particular events according to specific criteria relevant to the study. So a while ago, I gave you the example of this book carrying study, and we wanted to see if there might be some association between gender and particular styles of book carrying. Okay, so what we might do then is create the categories that we had: side carry, front carry, or everything else. But we might have a few cases that are borderline. We might have some cases where somebody is kind of in the front, but they're a little bit off to the side, and they're predominantly holding the weight of the book with one hand. Is that a side carry? Is that a front carry? We have to have a very specific criteria for figuring out how do we classify that particular unit of behavior into one of our categories. And we have to have some decision about that, presumably and preferably, before we start making our observations. So here's another example. In a study on bullying, maybe we're educational psychologists and we want to think about bullying in the classroom or bullying in the schools more generally. We might code a variable like physical aggression. Okay? Not all bullying is physical, but this might be one of several variables that we would have. Physical aggression, which would require person-to-person contact. Okay? So maybe one kid is pushing another, or is pinching another, or is pulling somebody else's hair. These would all be examples of physical aggression, and these are each exemplified by person-to-person contact. Okay? Okay, but not all person-to-person contact constitutes bullying. So we're going to need some further specificity. Suppose some child that we think is bullying is honestly shaking somebody's hand. They're not doing so in a aggressive manner. They are making no person-to-person contact, so we're going to need some more specific criteria to figure out whether a specific episode of person-to-person contact constitutes physical aggression. It might be the case that a child who is bullying is actually being embraced by a parent. And at that moment, it might seem like a very loving embrace. There's physical contact there, person to person. We probably wouldn't call that physical aggression. We need to come up with very specific criteria for what kinds of person-to-person contact constitute physical aggression. Okay? And we would code that behavior accordingly. And there are debates to be had here. There are clearly ambiguous cases about whether something is aggressive, for example, or not. Okay? This is one of the challenges of doing behavioral work. And you'll see that there are some cases where aggression, for example, really is quite clear. Okay, let's now do this. I'm going to give you a series of 4 potential pop quiz questions. We'll go through the 4 of these, and then at the end of the 4, then we'll ask you to stop the video and see if you can make your responses. And we'll come back into the classroom and we can share our responses and we can have some interaction between the students on these. Let's take some examples here, though. And this will require you to do some reading, which you can do in the textbook that we have for the course, or you might choose to go out to the internet or wiki and see if you can find answers to some of these if you're so inclined. Here's the first one. Please explain the concepts of reactivity and demand characteristics. Okay? So we've mentioned reactivity before. Now we're introducing a new one here called demand characteristics, and we're interested to know how you would explain those 2 concepts. Okay? So don't stop the video just yet. That's one of your pop quiz questions. Here's another one. Describe how habituation and desensitization are used to minimize the influence of the experimenter. And in our class, we're going to use these two words, habituation and desensitization, largely interchangeably. So if you get to one of these, you basically have the other. But how are they used to minimize the influence of the experimenter in a research study? That will be your second pop quiz question. Here's your third. Okay. In your own words, distinguish demand characteristics from expectancy effects. How are those different? Can you put that into your own words? And finally, our last pop quiz question. What is meant when a study is described as double-blind? Okay. If we have a double-blind study, what do we mean by that? Can you state that in your own words? So why don't you go ahead and stop the video, respond to these questions, and then turn the video back on when you're ready to go. Okay, welcome back. I hope you have the responses to those 4 potential pop quiz questions. Some of those might be administered as an actual pop quiz in class, and it would be worth 10 points toward the grade. In other cases, we'll just use them as conversation items and a chance for you to interact in the peer-to-peer learning that we think is so important. Okay, let's go on to our last concept, and this relates to the issue of reliability. To help increase reliability, and you might recall this is the repeatability of an observation, researchers often use a checklist with predefined behaviors. 2 or more observers independently check off whether the specified behavior is present or absent at a particular time. So we might be looking again at aggressive behaviors, and we might be requiring a necessary condition of person-to-person contact, although we said a moment ago that would not be a sufficient condition. And you and I might be observers, and we're looking at a particular child, and maybe I would check that this child is being aggressive at this moment, and you would not. Okay, so we might have the same checklist, and what we'd be interested in is some way of determining inter-rater reliability. You would be one rater, I would be another rater. And this is what we might do. We might use this formula for observer reliability, or inter-rater reliability, and we might set a criterion. Arbitrarily, we might set it something like 85%. That if we have inter-rater reliability of less than 85%, we think that maybe we need to tighten our construct. We need to tighten our operational definitions so that we can be more confident that we're actually observing what we think that we're observing. We have a greater consistency or repeatability on observing what we think we're observing. Okay? So we can look at the number of times the 2 observers agree, okay, over the number of opportunities to agree. So maybe you and I had 100 opportunities. We were given 100 minutes in which to make these observations. Okay? And maybe we agree 85% of the time or less. But this would be one of the ways of trying to quantify how 2 observers are either reliable or not so reliable. And as I mentioned a moment ago, we might have to go back to the drawing board and start our measurements again, firming up how we specify each of the behaviors of interest. Okay, so that's where we are. And we've now talked about lots of different things today. We talked about the measurement scales. We talked about other challenges and other considerations when we're engaged in observational studies. What we'd like you to do is now, in just a moment, stop the video. In fact, you can turn it off, and importantly, jot down what you found to be clearest in this presentation. And equally importantly, please jot down what you think requires further clarification. I look forward to seeing you and chatting with you in class on all of these topics. See you then.